Coming to DARPA is like grabbing the nose cone of a rocket and holding on for dear life.
DARPA is a place where if you don't invent the internet, you only get a B.
A DARPA program manager quite literally invents tomorrow.
Coming to work every day and being humbled by that.
DARPA is not one person or one place. It's a collection of people that are excited about moving technology forward.
Hello, and welcome to Voices from DARPA. I'm your host, Amber Corin. Microelectronics are found everywhere, from computers, mobile phones, and televisions, to automobiles, aircraft, and satellites. There are more microelectronic devices being utilized every day, and we are more dependent on them than ever. When supply chains were disrupted during the COVID-19 pandemic, it lifted the veil on a harsh reality. Our microelectronics supply chain is extraordinarily fragile, considering how much we rely on various types of microelectronics technologies. And that fragility is framed by economic and national security concerns, global competition, and the fact that the vast majority of microchips are manufactured outside of the United States. U.S. leaders are looking to change that, though, working to revitalize domestic manufacturing through policies and initiatives such as the CHIPS and Science Act of 2022, which was signed into law last year. DARPA has been involved in advanced microelectronics research and development for decades. Here's Dr. Stephanie Tompkins, director of the agency.
DARPA's role in the national security science and technology ecosystem is to make what we think of as pivotal investments, the things that will change the trajectory of technology and rapidly accelerate them on a much steeper curve. Within the ecosystem, our role is to take big risks and to push much further out into the future. So that is very, very much true within the microelectronics community as well.
This critical work continues to grow, including through DARPA's Electronics Resurgence Initiative, or ERI, which was announced in 2017. At present, with the announcement of ERI 2.0, DARPA seeks to reinvent microelectronics manufacturing with a distinct focus on future U.S. technological leadership. This concept was a focal point at DARPA's 2023 ERI Summit, which brought together, in person, DARPA program managers and performers, industry and academic leaders and up-and-comers, and government experts from both the defense and civilian worlds. In this episode, we're going to try to give you a representative sample of the entire summit in 20 minutes or less. But if you're looking for more or want to take a deeper dive, you're in luck. All 10 plus hours of presentations are available now on our YouTube channel, DARPA TV, and we'll have a link in the show notes. Let's start off with Pat Gelsinger, CEO of Intel Corporation.
What aspect of your life is not becoming more digital? Name it. Your banking, your social, what aspect of your job is not becoming more digital? And every aspect is becoming more digital, every mission that you're on, and everything digital runs on semiconductors. This simple idea of Moore's Law has been the singular driver of the greatest portion of innovation of the last 50 years. But the other wonderful thing that's happening, and even Gordon Moore predicted this when he wrote his initial paper on Moore's Law, that there will be a day of reckoning.
Welcome to the Day of Reckoning.
This is Dr. Mark Rosker, the director of DARPA's Microsystems Technology Office, which manages ERI 2.0. As a career physicist and engineer in the microelectronics space, and as a key leader in both ERI efforts, he has spent significant quality time studying the work of Gordon Moore, Intel co-founder and technology pioneer.
You know, we meet now at the most disruptive and most critical moment in microelectronics in our lifetimes. DARPA is about anticipating and creating technical surprise. And so it may not surprise you that when we recognize that a day of reckoning is coming, we roll up our sleeves. Which brings me to ERI 2.0 and what we at DARPA are doing in this moment of disruption. DARPA established ERI, the Electronics Resurgence Initiative, in 2017 in recognition of the importance of microelectronics to both national security and to the US economy. In doing so, we recognize a convergence in the great challenges like supply chain vulnerabilities and hardware security, both for defense and commercial electronics. ERI is a statement that we recognize how imperative it is for us to work together to solve these problems. Now we have begun ERI 2.0, and ERI 2.0 seeks nothing less than to reinvent the integrated circuit, moving from the monolithic to the assembled era. Let's go reinvent microelectronics manufacturing together. It's going to be fun.
The microelectronics revolution that is underway in the United States is emanating a lot of vibes. Sentiment around the challenges the country faces and the steps being taken to address them really varies. Many people and communities are driving forth their sense of urgency. Some are worried. Some are feeling patriotic. Some are relieved, especially those who will obtain jobs created through the CHIPS and Science Act. And some, such as scientists and researchers and engineers, sound like Mark Rosker. They're excited.
Research is fueling optimism in our society and world.
This is Dr. Laura Weiss, Director of the CHIPS Research and Development Office at the U.S. Department of Commerce.
And that is why the research and development component of the CHIPS and Science Act is so critical. Okay, so while a lot of semiconductor innovation and design really happens in the U.S., we do need a global, holistic, robust, and inclusive R&D ecosystem here to support the growth that we're just talking about in chips and manufacturing that Chips for America is bringing. We need prototyping and testing capabilities for entrepreneurs, large companies, small companies, industry, academia, everyone, for them to be able to go into these prototyping facilities. We need researchers and developers that can have more access to these facilities and equipment, and design tools and data sets that we can make accessible to all of those doing the research and development.
When COVID-19 ripped away any illusions about supply chain security, everyday Americans who previously knew little to nothing about microchips suddenly learned a lot about them. For perhaps the first time, they felt the effects of a microchip disruption. It became difficult to purchase cars, and buying electronics cost more and took longer. The legislation aimed at shoring up U.S. microelectronics is the most visible and biggest investment in a government-wide effort to tackle the issue. But it's not the only one, as Dr. Tompkins explains DARPA's contributions.
I think it's worth pointing out that while we collaborate constantly and very closely with all of those organizations and are making sure that we are synergistic in many ways with folks who are executing on chips and science, our funding is actually entirely independent. We are investing well over $3 billion over the next 5 years, focusing on what is after next. So we really are thinking long-term, in keeping with DARPA's mission and those pivotal technology changes. What are the technologies that will cause technological surprise and enable those massive transformations in the coming years?
DARPA is looking for those pivotal technology changes to impact the two thrust areas new to ERI 2.0, manufacturing complex 3D microsystems and developing electronics for extreme environments. Let's tackle those in order. For manufacturing complex 3D microsystems, here's Dr. Carl McCants, Special Assistant to the DARPA Director for ERI.
We are at a point of manufacturing inflection. And please keep in mind that it's these manufacturing capabilities that have allowed us to move forward. Manufacturing is a foundation, great ideas, great thoughts. Yeah, this is conceivable. If I can believe it and conceive it, I can do it. However, if I can't make it, then I don't get the full benefit. So what we have now is primarily 2D, 2.5D, monolithic integration, primarily silicon, and packaged after fabrication. Where we at DARPA believe that we're moving to is 3D, and I'll also say 3.5D, where you combine stacking with interposers to, again, bring you different aspects, different capabilities, different ways of putting all these things together.
Continuing the thread of creating the 3D microsystems of tomorrow, here's Dr. Anna Tauki-Pedretti, Program Manager in DARPA's Microsystems Technology Office.
It will be key to both develop new innovative technology and to build a robust infrastructure. From a technology standpoint, individual chips will no longer be accessible, requiring new failure analysis methods. The close integration of chips composed of a diverse material set will push us towards new thermal management methods. And the ability to share and utilize data across chips will become increasingly important. Now let's consider the infrastructure. The creation of a successful ecosystem will make 3D HI accessible to the government, universities, and small businesses for prototyping and small volume manufacturing, while continuing to develop to meet the needs of large volume markets.
Here's Dr. Josh Fryman, fellow at Intel Corporation, talking about some of the new applications enabled by complex 3D microsystems.
A grain of rice, according to NIH, right? The average size of grain of rice using the same techniques, I can put all of the compute silicon in this and a half a terabyte of DRAM. So I want you to just pause and think about holding a grain of rice in your fingers that could do that level of compute. What would you do with it? I can't cool it. I can't power it yet. That's a DARPA hard problem. I don't know how to connect it to something. That's a DARPA hard problem. I don't design and validate. That's a DARPA hard problem. But you can see the applications that are potentials in front of us. Imagine you can make this a fractal design. I have interleaving toaster slices, pancake slices in different geometries coming together in pluggable modules. This is, I'm going to argue, a far more intelligent and efficient way to build these things. But there are a lot of DARPA hard problems.
DARPA hard problems also lie at the heart of the other new ERI 2.0 thrust area, developing microelectronics for extreme environments. Here's Dr. Matt Francis, President and CEO of Ozark Integrated Circuits.
What problem were we trying to solve with high temperature? Well, how do you sensor control in an extreme environment? Imagine trying to control a jet engine, trying to steer a drill underground for energy exploration, control a nuclear reactor, or even maybe land a vehicle on Venus. These are places that are very hot with extreme vibration and likely radiation as well. Most electronics we have today simply can't take the heat, and the current solutions, they tend to be very custom, very expensive, or in some cases they don't exist. So moving to high temperatures means we have to look at new materials, but we have to also look at all these aspects together. And this requires the development of new standards and methods to validate them, as we're going way, way off the end of the temperature ranges that we're all used to. But the systems have to be designed as a whole: semiconductor, package, and integration, if they're going to survive and thrive. This requires us all to work together, from fundamental materials development to semiconductors, modeling, design, packaging, yes, and definitely test, and developing those new standards that drive this new area of rugged computing and electronics.
Now let's look at another domain that is driving the innovation of and demand for microelectronics: artificial intelligence, or AI. How are microelectronics enabling and enhancing the capabilities of AI and machine learning algorithms, both in the cloud and at the edge? In full disclosure, those last two sentences of narration were actually written by an AI chatbot. Here's Dr. Bill Daly, NVIDIA Corporation's Chief Scientist and Senior Vice President of Research, with his perspective.
It's really been a very exciting time to be a computer engineer. Unless you've been hiding in a closet somewhere, you've seen the revolution in generative AI taking off. Most of us have spent at least a weekend playing with ChatGPT, asking it to write stories to read to our kids and things like that. And it's amazing how good it is. GPUs have been the enabling technology, both for deep learning and for electronic design automation.
With further thoughts on the intersection of microelectronics and artificial intelligence, here's Mark Papermaster, Chief Technology Officer and Executive Vice President at AMD.
It's so personally fulfilling when you've had 4+ decades like I have in this industry to see the very chip designs we work on being able to power such a demonstrable, immediate, and tangible improvements to our productivity. It ain't slowing down. Right? We're seeing such a tremendous growth of compute capacity. The reason is very simple. All of the old demands that you had on computing, that you ran your lives on before these new AI capabilities came about, they didn't really go away. What you're adding on top of it is predictive and generative AI capabilities. And so it's creating basically a double exponential.
MTO Program Manager John Davies continues the thread on AI, pulling it out further to the edge.
Every day, it feels like we hear about a new breakthrough. What do all of these breakthroughs have in common? Massive amounts of advanced computing. In order to unlock the secrets buried within massive data sets, takes data centers consuming kilowatts and megawatts of power in enormous clusters and networks of advanced processors. As we look to the future, what we really want to enable is true edge intelligence. That is, systems that are able to autonomously sense, decide, and act under the messiness of the real world, while using only a tiny fraction of the power of today's AI data centers. What's the biggest thing standing in our way? Uncertainty. And when I say uncertainty, I mean deep uncertainty. These are things that we don't just not know, but things that are actually unknowable.
One thing about microelectronics that is certain, the need to maintain security throughout the entire life cycle of the hardware. Dr. James Wilson, MTO Program Manager, weighs in.
Every one of these microelectronics has an interface to the real world. That could be digital, it could be analog. It's usually intentional, but sometimes it's unintentional. And it is these interfaces that we spend a lot of our time, these intentional interfaces, trying to protect. This is really the front door for security. We put the deadbolt on it, we lock it really tight, but sometimes we're not as concerned about the open window that we have on the side, and these are those unintentional interfaces. People are using the interfaces in ways that we didn't think about. And it is sort of the proliferation now that we have of the silicon around us everywhere with all of these interfaces that is really motivating our interest in security for silicon microelectronics.
The use of these technologies is critically important. Microelectronics for missions. If these advances aren't crossing the valley of death between concept and fielded capability, are they making a difference? Here's Dr. Patty Chang Chien, Vice President and General Manager of Boeing Research and Technology.
The mission requirement, a lot of times there's a new mission. You don't even know what the requirement is. Maybe it's exploratory. So we do a lot of demonstration and certainly a lot of feasibility study and trying to get us there. 10 out of 10 of your customer, my assumption, is going to say, if you have a 100% solution in 5 years and you have a 2-year solution to give me only 70, they will pick the latter because the technology and the capability is needed yesterday.
These capabilities, enabled by MTO and the microelectronics ecosystem, are needed by industry, government, the military, and even other tech offices at DARPA, including the Strategic Technology Office, STO. Dr. Whitney Mason is a former MTO program manager and the current deputy director of STO.
What STO likes to do is very rapid programs that are extraordinarily disruptive, change the conversation. If it's on your roadmap right now, that actually doesn't interest us. It is about making it make a difference, changing that conversation and using it in new and interesting ways. A couple of the things that we think are technologies that are ripe for use, although I will acknowledge that we're not really sure how we would use them, quantum technologies and advanced photonic integrated circuits. The community has done an amazing job at massively advancing where these things are, and we think that's the right time to start thinking about how we can use them.
Breakthrough technologies and the capabilities they enable, that's DARPA's mission. Longtime listeners of the Voices from DARPA podcast might recognize our next speaker as the terahertzian from way back in episode 4, Dr. Dev Palmer, who was also featured in episode 65, talking about Jump 2.0.
So about 10 years ago, I was a relatively new MTO PM, and I got on the elevator one morning and realized I was riding with a former astronaut, a Navy SEAL who had been detailed to DARPA, and a serial entrepreneur who had been in Silicon Valley and started and sold about 10 companies. Now, of course, my first thought was, what the heck am I doing here? But my second thought was, good grief, what a bunch of accomplished people and what an incredible place to work. And it really is an incredible place to work. When you're a DARPA PM, you have a broad overview of the science and technology enterprise across the nation. And you have unmatched access to researchers in academia and industry. And on top of that, you have access to all the DoD government labs, agencies, and personnel that you can learn from. You come to DARPA with a big idea. What you can accomplish there is limited by what you can execute. And it's even better than that because on any given day, there's about 100 PMs, and there's 10 times that many people in the organization who are there to help you do your job. And if you do your job, you can personally change the trajectory of technology at a national level. It's just amazing.
Of course, DARPA PMs don't do all of that in a vacuum. It takes the entire innovation ecosystem of academia, government, and industry to make all of this work. And, as DARPA Director Dr. Stephanie Tompkins notes, collaboration among all these parties is critical for success.
Bottom line is, talk to us. Bring us your ideas, ask questions, learn about what we're thinking about, help us to create the next generation of programs, and be all of the people upon whom we will be placing many, many bets regarding the high risk but potentially enormous payoff in the future of microelectronics.
That's all for this episode of Voices from DARPA. As we mentioned at the top, all the presentations from the 2023 ERI Summit are available on our YouTube channel, DARPA TV. That link will be in the show notes, as well as other relevant links to the Electronics Resurgence Initiative 2.0 and the Microsystems Technology Office, in case you'd like to explore further. Thank you for listening. Okay, we couldn't figure out how to fit this into the episode. And you won't find it on the YouTube playlist, but I had to include it somewhere. This is Carl McCants, Special Assistant to the DARPA Director for ERI. You heard him earlier in the episode, performing his own walkout music all about 3D heterogeneous integration and next-generation microelectronics manufacturing. It's just wonderful.
Let's stack it up, let's go 3D instead of monolithically. NGMM will get us to the next phase technologically. Phase 0 now defining microsystems for our future needs. We'll get there, but we need your expertise. Won't you join with me?
Thanks for sticking around for that. I hope you enjoyed it as much as we did. Special thanks to Tom Shortridge for producing this episode.